The list view starts by requesting a view for every visible item, however many you can fit onto the screen. It'll also create a couple in either direction, to make sure that we can scroll without seeing a flicker as a new view is created and populated. Then it creates new items just in time, so it's next in line to be visible to the user. So if the user never scrolls to the bottom of the list view will never request that view from the adapter. But this is really just a half measure. As you can see, if the user keeps scrolling, we could potentially just keep adding new views, even if they disappear off the top of the screen. Eventually that's going to lead to the same impact on memory use and performance as if we had just created all of these views directly at the beginning. The solution is recycling each view as it scrolls off the screen, allowing it to be reused when we need to show another item as it moves into view at the top or bottom. So rather than having to create and then hold in memory each item of the list as it comes into view, we only need to do the creation step for the number of visible items and a couple on either side. Then, whenever a new list item comes into view, we just update the data displayed in one of the items in our recycle bin. The result? Less memory overhead, smoother scrolling, and less view management you have to do yourself. This same recycling behavior is implemented across all adaptive view descended classes, such as GridView and ListView, which also introduces the reason that the adapter isn't built directly into these controls themselves. By keeping them separate, your adapter defines how to display each element of the underlying data, while the adaptive view implementation itself is responsible for controlling how each of these elements is laid out, be it a list or a grid in these particular instances.